All right, welcome chemistry class. We're going to start chapter 6 for our notes today. So we're talking about chemical bonding, and I'm going to kind of go fast through here, so please feel free to stop the video whenever you'd like. Okay, first off, chemical bonds. Got to have a working definition for that. It's a mutual electrical attraction between the nuclei of atoms, and it has to do again with those valence electrons. So a quick definition, hopefully you already know what valence electrons are. We've talked about this in our last chapter. Couple points about valence electrons. In chemical bonds, valence electrons move from one element to another, or they're shared. Those are the two ways that we can do this. Either they're sharing or they're exchanged. And again, we can figure out valence electrons using the electron configuration, and we also figured that out using our periodic tables, and we're going to review that today as well. One of the important things here is the octet rule. All right, hopefully you guys can see that. I know my head's getting in the way, but a chemical compound tends to form so that each atom, by gaining or losing electrons, can have 8 in the outer shell. That's that 8 is great rule. Again, feel free to stop this video at any time if you need to jump ahead, or I'm going too fast. So I'm going to go ahead and skip this slide. We already talked about our valence electrons. Types of compounds. Okay, so again, we're going to have two major types that we'll talk about today, or not today, but in this chapter. First one that we're going to talk about today is ionic compounds. These are made up of a metal plus a non-metal. And how do you tell if it's a metal or a non-metal? Well, you just look at the periodic table. If it's to the left of the stair-step line, it's a metal. If it's to the right, it's a non-metal. Okay, so that's how we tell. And we have specific names for these guys. They're made up of ions. Okay. Oh, and these ionic compounds always have form smallest whole number ratios, and they're made up of ionic bonds. Ionic bonds form between cations and anions, and they're exchanging their electrons. This will become a little bit more clear as we go. Some examples of ionic compounds: sodium chloride, metal, nonmetal; calcium oxide, calcium and oxygen, metal plus a nonmetal; magnesium hydroxide, metal plus 2 nonmetals. Okay. Ions. Again, ions are elements that have lost or gained electrons. Basically, they got a charge. So if you lose an electron, you get a positive charge. You gain an electron, you get a negative charge. And we have two types of ions. We have cations, which have positive charges, and they're almost always metals, while our anions are negatively charged, and they're almost always nonmetals. That's not a blanket rule, but usually, again, they're almost always non-metals. And how can you tell if it's going to be a cation or an anion? You're going to get a pink sheet along with this that has these all listed out for you. Otherwise, if it's to the left of the stair-step line, it's a metal. It's probably going to be a cation. If it's to the right, a non-metal, it's probably going to be an anion. All right, we're going to keep zipping along here. For charges, so here, take a look at a periodic table. You're going to want to write this onto your periodic table. These guys in the first column have a +1 charge. That means they form a +1 ion, which makes sense because they have one valence electron in that column, so they want to get rid of that one valence electron. When you lose an electron, you gain a positive charge. Second group, they have 2 valence electrons. They want to lose those electrons to be happy to get a full outer shell, 8 in the outer shell. So they have a +2 because they usually lose. Again, it varies for our transition metals. And we come up here and we see that 13, group 13, again, usually has 3 valence electrons, so it wants to get rid of those 3 valence electrons. Now, in the group 14, it's a metal. It's going to want to get rid of its electrons, so it would be +4. If it's a non-metal, it might want to gain. So something like carbon usually wants to gain more electrons, so it's going to gain 4 more instead of losing those 4. Here, 13, or sorry, not 13, group 15 have 5 valence electrons. That means they want to gain 3 more to be happy to make 8. So they usually have a -2 charge. Group 16 usually wants 2 more, so they have 6. They need 2 more to be happy. And then this last group has 7, so they just want to gain 1 more to be happy. And then again, the noble gases don't need to gain any. They're 0. They don't form ions. They don't form bonds. All right. We're going to go through a quick few rules for formulas, ionic compounds. We're giving names, then I'm going to have a little tutorial you can look up linked in Schoology. So first, determine the charges of the ions in the periodic table. So you can look at the periodic table if you same thing you just looked at, if you label your periodic table that we just looked at. Otherwise, there's going to be a pink sheet available that has it all laid out for you, and I'll leave those. Using the crisscross method, we're going to determine subscripts, and I have a tutorial to show you that. I'm not going to try to verbally tell you how to do that. Number 3, then check to make sure your subscripts reduce. So if it's 2 and 2, you can reduce it down to 1. If it's 2 and 4, you reduce down to 1 and 2. Okay. If it doesn't reduce, then you're finished. If you need to reduce, and then you're finished. All right. So that's my really quick rundown of this first part of your notes. We'll go one more slide. Again, the tutorial, please watch that. It's a little handwritten one on the iPad, so you can actually see how to write these. And again, we'll go over this when I come back. So writing their names, super, super simple for these guys. So when we're writing these names, we just write the name of the metal, okay, it's usually capitalized, and then the name of the nonmetal, it's usually lowercase, and we give that nonmetal an "-ide" ending, tells us it's turning into iron. So we have sodium and chlorine, we have sodium chloride. Okay, next one, magnesium and chlorine, magnesium chloride. We can ignore those subscripts because it doesn't matter. There's only one way they can form because they're ionic. Same thing, rubidium sulfide. And last one, we're going to get to this a little bit later, but we have iron and oxygen, so you think it'd be iron oxide, which it is, but with transition metals, we have to include a Roman numeral to tell us what charge it is. We'll pick up here with this when I get back. I don't want to try to do this over a video, but here's, so you have the first part of your notes ready to go, so you can copy this in your notebook. Please watch the tutorial that's on Schoology, and we'll talk about it when I get back. All right, good luck.